Now, we will discuss the nodal analysis. So, what is nodal analysis? Nodal analysis is an electrical network analysis method in which it is used to determine the voltage on a various circuit nodes. So, what is the difference between nodal analysis and mesh analysis? Nodal analysis use KCL, or the Kirchhoff's current law, while on the other hand, mesh analysis use KVL, or the Kirchhoff's voltage law. So, we are actually here given a circuit. Using nodal analysis, we must to follow 3 steps. So, the first step is determine how many nodes are there in your circuit. So, there are 1, 2, and 3. And then, determine what is your reference node. Your reference node will be the zero potential node of your circuit. So, it will be here. And then, label the unknown and known voltage level on the other nodes. So, let's say it is voltage A, and this is voltage B. Step 2, label the unknown and unknown currents flowing in your circuit. So, let's say it is current I1, current I2, current I3, current I4, and current I5. So, finally, the last step will be the KCL. So, we will determine the voltage here. So, using KCL, let's write I1 is equals to I2 plus I3. But I1 is equals to V1 minus VA all over R1 is equals to I2 is equals to VA minus VB all over R2, and plus I3 is equals to VA all over 4. That will be our equation 1. So for voltage V, let's write I2 is equals to I4 plus I5. But I2 is equals to VB minus VA all over R2 is equals to I4. I4 is equals to VB minus V2 all over R3 plus I3 is equals to, I5 is equals to VB all over R5. So, let's assume here that the all resistor and the 2 voltage source has a value. So, we have 2 unknowns variable, which is the VA and VB. And since we do have 2 equations here with 2 equivalent equations, therefore we can solve the 2 unknowns.
So, to better perceive the picture, we will solve this given circuit using our nodal analysis. Nodal analysis utilizes KCL, or the Kirchhoff's current law, in order to solve the voltage across a node. So let's begin. In nodal analysis, we must first identify how many nodes are present in our circuit. Given this circuit, we have 3 nodes present. Node 1, which we will name node A. Another node, which we will name node B. And our reference node on the bottom. The reference node is the common node between all the nodes. So, applying KCL on each node, we will assume the direction of the current to be from the EMF entering the node and leaving the node. So, this will be our current 1, current 2, current 3. Same is true for node B. Current 3, current 4, and current 5. Now, applying KCL on each node, we have at node A, the current I1 will be the voltage flowing through this resistor over the given resistor. So that will be 20, or our EMF minus the voltage on node A all over our resistor, which is 10. So in KCL, it states that the current entering the node will be equal to the sum of the current leaving the node. So our equation yields voltage on A all over 40, or our resistor, plus voltage across this part all over the resistive component, which is 20. So that will be VA minus VB all over 20. Rearranging the equation, we will have and this will be our equation number 1. Now, applying KCL on node B, we will have the voltage across segment AB all over the resistive component, which is 20. Will be equal to the sum of the current leaving the node B, which is voltage B all over 50 plus voltage B minus our EMF source, which is 10 all over 30. Rearranging the equation, we will yield this will be our equation number 2. Solving these two equations simultaneously, we can now get the values of VA and VB, which will yield to volts, and VB will be equal to 10 volts approximately.
So now we're going to give you another special technique for you to answer complex circuit. And this technique is called source transformation. So as the name states, source transformation is transforming your given source into its opposite type for you to answer or analyze the circuit into a simple way. So we have here a problem in which we are going to solve for the current Ix. So since we can answer this by using mesh analysis, and that we have two types of sources, which is voltage source and a current source. All we have to do is change this current source into its opposite type, or the voltage source. So now we have here V is equal to IR. So V is equal to, since this is a current source, all we have to do is get 10 amperes the current times the resistance R, which is 8 ohms. We have voltage is equal to 80 volts. And then the drawing our circuit, we have copying this part of the circuit as it is. We have angle 0 degrees volts. We have here 4 ohms, and then 2J, and the missing current Ix, and then another inductor with 5 milliohms, and then this time the 8 ohms that we have here should be series with respect to the circuit, with respect to the source. And the current source will be a voltage source now. So we have here 80 volts, and then current 8 ohms. So as you can see, we can now solve this current Ix by using mesh analysis, in which we have here loop 1 with the current I1 and loop 2 with the current I2. So now let's solve for the equations. So a while ago, we already have loop 1 for current I1 and loop 2 for current I2. So now what we're gonna do is that we're gonna solve for the value of Ix, or the current at the inductor 2J, by using mesh analysis. So for loop 1, we have, for loop 1, we have the voltage source 20 volts minus 4 I1 minus 2J I1 minus 0. And then let's have the voltage at the loop 2. So for loop 2, we have 2J I2 minus I1, and then minus 2J we have 8 plus 0.005 J I2 minus AB. So let's have the equation for loop 1 as our equation number 1. While the second equation for loop 2 will be our equation number 2. So after having equation number 1 and equation number 2, we'll now have the value of I1 and I2 by solving the equations simultaneously using mesh analysis. So I1 is now equal to 0.6019 plus 0.8016 J ampere. While I2, or the current at the second loop, will be equal to 2.2051 plus 9.5978 J ampere. Since we already solved the value for I1 and I2, all we have to do to solve Ix is to subtract I1 and I2. Therefore, Ix will be equal to negative 1.5996 minus 9.1562 J ampere. So that is how to solve a certain complex circuit by using source transformation and mesh analysis. Thank you.